Hello everybody, welcome to Cumulative Review number 17. We're going to be starting here with number 38, which is starting the sequences and series portion. So, write a recursive rule and a general explicit rule to describe the sequence. So the first thing we need to decide is if this sequence is arithmetic or geometric. That might help. So if we take a look at the sequence, it looks like we are consistently going up by 10 units. And so some of you might like the fact that this has to be arithmetic, because arithmetic sequences go up or down by subtraction. Geometric sequences usually increase or decrease by multiplication or division. And so if I were to first find a recursive rule, recursive means depends on the previous term. So this would be a sub 1, a sub 2, a sub 3. And so you could continue this forever and think a sub n. And so you're thinking to yourself that I am always taking my previous term and adding 10 to it. Because if I keep going, I'm going to keep adding 10 to 65, add 10 to 75, add 10 to 85, and so this would be my situation. The only thing that I realize is missing here is we need to say where we're starting. This is true if your first term is 25. The general or explicit rule could be found two ways, actually, and it depends on you. I'll do both, and you can choose which one you like more. So the first way that we did this at the beginning of the unit was we wrote n equals 1, 2, 3, 4, 5 above all of the numbers. And we used 10 as a slope because it was linear. We said, okay, let me take this n value and multiply it by 10. And if I do, I'd get 10. And then we asked, how did we get from 10 to 25? We added 15. Then we took the 2 and we multiplied it by 10. We got 20. Then 20 plus 15 again gets me 35. So we generalized and made the formula. I take the n term, multiply it by 10, and then add 15 to get to my output values. And so my answer is definitely 10n plus 15. But I remember some of you didn't necessarily like the guess and check method. So if you're interested instead, if you know this sequence is arithmetic, you could use the arithmetic formula instead of the guess and check method. So you could use a sub n equals a sub 1 plus d times n minus 1. And the common difference is 10 because we're constantly increasing by 10. The first term is 25. And what we can do is just simplify this and get the a sub n term. So some of you might like this because it's a little bit more formulaic and less guessing. 25 plus 10n minus 10 if I distribute, which would reduce to a sub n equals 10n plus 15. So either way, you get the same answer. So sometimes it is helpful to ask yourself if it's arithmetic or geometric at the beginning of the problem. It also helps to answer part B. Find the sum of the first 60 terms of the sequence above. If the sequence is arithmetic, that means I'm trying to find an arithmetic sum. And what I would suggest doing is anytime you see the word sum, I would draw the summation symbol. What we're doing is we're going from the first term, n sub 1, or n equals 1, to the 60th term. And what we're doing is using the equation that we just found, 10n plus 15. So we're trying to find the sum more quickly. Again, what we could do is plug 1 all the way up to 60 into this function and add the results, but it's faster to use the quick little formula, which is the sum is n over 2 times a sub 1 plus a sub n. And what I want to remind you of is that n represents the number of terms. A sub 1 represents your first output value, and a sub n represents your last output value. The reason I say output value is when you have a sequence, what you're actually given here are the output values, because the input values are 1, 2, 3, 4, 5. And so here I'm inputting 1 and 60, so I need to figure out what my output values are. But first, the number of terms. If I'm going from 1 to 60, that is 60 terms exactly. So I'd have 60 over 2 times. My first term, you could find it two ways. Either you could look back at the original and say that the first term is 25, so you'd plug in 25 here from a sub 1, or what you could do is plug 1 into my 10n plus 15, and if I do that, I also would get 25. That leads me to how to find the last output, or the last term. It's really tempting to put 60 here, but 60 isn't an output value, it's an input value. So to find my output value, I need to plug 60 into my function, which would be 600 plus 15. So my output value would be 615. So if I plug this into the calculator in a little bit, 60 divided by 2 is 30. If I add 25 plus 615, that equals 640. If I multiply 640 times 30, I get an answer that my sum is 19,200. So my answer here, 19,200. The next example says, find the nth term, and another way to say the nth term is find the general term. And this time it tells you it's arithmetic, with the third term being 15, or the output value is 15, and the seventh term, the output value is negative 13. Then we're going to use that to find the 32nd term. So if it's arithmetic and I'm trying to find the nth, I'm eventually trying to get my answer to be in this format initially, which means I need to know the common difference, and I need to know the first term at least. So in order to find the common difference, because arithmetic is linear, the common difference is really the same thing as slope. And so to find slope, I'm going to think about these as points, 3, 15, and 7, negative 13. So if I find the slope, negative 13 minus 15, y2 minus y1, over x2 minus x1, I would get negative 28 over 4, which would get me a common difference or a slope of negative 7. So that means I would plug my negative 7 in for D. I also, though, need to find my first term, because the two most important things, again, are the common difference and the first term. And so what I can do is think about, if I'm given these 2 points originally, I can use one of these 2 points and help me find a sub 1. Because if I think about the point 3, 15, what that really means is my input value n is 3, and my output value a sub n is 15. So I could plug 15 in here, keep a sub 1 alone because I'm trying to solve for that. There's my common difference, and my nth term I'm plugging in is 3. So we'd have 15 equals a sub 1 minus 7 times 2. So 15 would equal a sub 1 minus 14. So if I add the 14 over, I get that my first term is 29. Now that I have my first term and my common difference, I can plug them both back in and get my general equation. A sub n would equal the first term of 29 plus the common difference of negative 7 times n minus 1. If I distribute the negative 7, we get 29 minus 7n plus 7. And so my final general term would be negative 7n plus 36. So that would be my nth term or my general equation, but now we would like to use it to find the 32nd term. So if my goal is to find a sub 32, all we have to do is plug 32 into my function. So negative 7 times 32 plus 36 is really going to be negative 224 plus 36, which gets me a final answer of negative 188. The next example, 40, also wants me to find an nth term, or a general term, but this time it's a geometric sequence, and it gives me the 7th term is 5, and gives me that the common ratio, or how I'm multiplying and dividing constantly, is 1/2. Then I want to find the 20th term. So just like the previous example, we have a formula for all geometric sequences, and it is a sub 1 times r to the n minus 1. And the most important things in this equation are the common ratio, which we have, and a sub 1, which we do not. And so let's plug in what we have. A sub n equals a sub 1 times 1/2 to the n minus 1 power. But just like number 39 in the arithmetic, we can take this point that we have, 7, 5, and think about that 7 is the input value n, and 5 is the output value a sub n. So I could have 5 equals a sub 1 times 1/2 to the 7 minus 1 power, which is 5 equals a sub 1, 1/2 to the 6th. If I reduce this without a calculator, 1/2 to the 6th power, and I don't even think I need these parentheses anymore here. 1 to the 6th is 1, and 2 to the 6th is 64. And so what I could do quickly to get a sub 1 alone is I could multiply both sides by the reciprocal to get a sub 1 by itself. So I would have a sub 1 equals 5 times 64, which gives me 320. So if I wanted to find my general equation, a sub n, again, equals a sub 1 times r to the n minus 1 power. We now know our two most important items. We know that the first term is 320, and we know that our r is 1/2. So my general term would be 320 times 1/2 to the n minus 1 power. And then the problem wants me to continue to find the 20th term. And so if I'd like to find a sub 20, all we're doing is taking the 20 and plugging it in for n. So we'd have 320 times 1/2 to the 19th power. This example over here I kept exact because it was not too bad, but this example I would suggest leaving as a decimal because when you plug this in the calculator and follow the order of operations and you do 1/2 to the 19th power first, then you multiply by 320, your calculator is going to spit something like this out, a 6.1 e to the negative 4, which is really scientific notation, 6.1 times 10 to the negative 4th power, which really means it's a really small number. Then I'm starting at 6.1 and I'm moving my decimal 1, 2, 3, 4 units to the left. So my answer is really small. It's 0.00061. So next we're going to go to number 41, which is asking about a recursive sequence. And the recursive sequence says that the next term in the sequence is the previous term minus 3 times 4, if the first term is 2. We need this in order to know where to start. So if I'm trying to find my second term, what I'm going to do is take the answer to my first term and plug this in for a sub n. Because you're really saying a sub 2, what you're really doing is saying a sub 2 is equal to 4 times a sub 1 minus 3. So that would really be 4 times 2 minus 3, which would be 4 times negative 1 or negative 4. If I want to find a sub 3, I take the answer from my previous and plug it in, because a sub 3, which is n plus 1, 1 less is a sub 2. So you're really finding 4 times a sub 2 minus 3, which is really 4 times negative 4 minus 3, which is 4 times negative 7, which is negative 28. If I want to find a sub 4, you are taking the previous term and plugging that in for a sub n. So to speed it up a little bit, it would be 4 times negative 28 minus 3. So that would be 4 times negative 31, which is negative 124. So my fifth term is 4 times my previous term, which is negative 124 minus 3, which is really 4 times negative 127, which is negative 508. These numbers are increasing rather quickly. Last but not least, to find a sub 6, we're doing 4 times my previous term, which is negative 508, subtracting 3, which is 4 times negative 511. 4 times negative 511 is really negative 2,044. All right, so the last two problems, the sum problems, I'm going to leave for the next video. It'll be shorter, but I don't want to rush these two. So 42 and 43 on the next video. Thank you.